Saram to all of you. Having seen the occurrence of metals, having seen how to get them out of the earth's crust and then concentrating those ores, we now need to target on the purification of metals. But before we purify metals, we first need metals in crude form. What is the meaning of this crude form? Crude indicates that it is only the presence of metal, but not highly purified condition. This I can explain you with the example of silicon, germanium metals which are used in all this electrical as well as other systems which are being placed where they need a purity of around 99%, 99.9%, 99.99%. So, extraction of a crude metal will not give you that purity, but at least it will give you a crude form of a metal where there will be no other components along with that metal. So, what is that aspect here? In this we will see where we will look for three different processes that we are going to employ in this. The first one I am going to call it as calcination. So, what is calcination? Calcination is extraction of a metal mainly in the absence of oxygen or air. The moment we say air, though nitrogen percentage is 78%, it is an inert gas, it does not react. But oxygen, which is 21%, does react in a good form. So, therefore, whenever we tell utilization of air, we mainly mean the presence of oxygen. This process does not utilize air, where if we take an iron oxide which is in hydrated form, this iron oxide when we undertake heating we can obtain Fe2O3 plus XH2O. What has happened here is that the hydrated form, the water component is eliminated from this ore due to heating. So, what is the definition of calcination I can give by seeing this reaction? I can tell it that heating of ores at high temperature leading to corresponding oxide forms which are there. Why do we need to go to oxide form is that we know very well a process called as oxidation or reduction. What is reduction? Reduction is removal of oxygen, and we have many processes of reduction which we would have studied in organic chemistry or some process which we will study specifically for metallurgy. So, getting directly from hydrated form extraction of metals will be difficult. So, the best thing is to convert all forms which are there into oxide forms and then employ reduction, so that removal of oxygen will give you the corresponding metal. Let us go to some other forms like zinc carbonate. This zinc carbonate, when I undertake heating, I can obtain zinc oxide plus carbon dioxide. Why do I need this zinc oxide? Is because application of reduction process is easy on oxide. It is not going to be easy on carbonate because there is carbon also which is present, and my requirement is only zinc metal. So, therefore, once again to define this calcination process, heating of ores at high temperatures to obtain its corresponding oxides, we can define it as calcination. The further part now then, if this is one process, another process let me show here for a comparison, and that I am going to call it as roasting. We heated compounds here in the absence of air or oxygen, but in roasting we do utilize air. Why do we utilize air? That let us understand with the support of one example. Let me take another form of zinc which is obtained as zinc sulphide. Now, if I want to convert this zinc sulphide into zinc oxide, naturally the sulphur has to be replaced by oxygen, and in this case there is no oxygen available in this compound. So, if I have to implement an oxygen in this, I need to react it with oxygen, so that the byproduct that I am going to get is sulphur dioxide. So, what is this process is? It also involves heating, but this is in the presence of oxygen. Please look into the balancing part. This happens to be 2SO2, 2ZNS. This is the balanced form where we know very well that balancing is a trial and error method. What is the difference that we see in these two is, here oxygen is part of the ore and you are only removing those which are not required. But here oxygen is not part of the ore, and therefore you need to supply oxygen so that you get an oxide form of the ore. Another example for this, we can take copper sulfide, treat it with oxygen, heat it, we will tend to get copper oxide, and once again sulfur dioxide gas is being eliminated in this case. So what is the balancing part that we see here is, we can take this as 2C2, 2, 4 coppers on one side, 4 copper here, 2 sulfur atoms, this side 2 sulfur atoms. The product side now has 6 oxygen, so therefore we can use this as 3O2. Difference between these two, this is in the presence of oxygen, this is in the, this is in the presence of oxygen, this is in the absence of oxygen. Why do we need to employ this process? Is because in these cases oxygen is part of the ore, whereas in these cases oxygen is not part of the ore. That is why you have to supply oxygen and make the oxide form. While these two processes help us to get into their corresponding oxide form, we are yet to obtain metals in this case. And how do we obtain metals here is, we employ reduction process. So when we want to go through this reduction process, we need to know what is the definition or what is the implication of reduction. So reduction to obtain crude metals. Now, the best reducing agent that we can have is carbon or carbon monoxide. The reason is, carbon can react with oxygen to form carbon dioxide. Carbon can also react with oxygen to form carbon monoxide. This is the balanced part of the reaction. Also, carbon monoxide can react with oxygen to form carbon dioxide. Once again, looking into the balancing part. What we understand by this is, if I take carbon metal or if I take carbon monoxide, we can react it with oxygen to form their corresponding oxides. And where these oxygens will be available is in those compounds which have oxygenated oxides in them. So employing these criteria, let us see now in the next aspect. So what is the next part here is, if I utilize carbon, I can get the corresponding ores which are being present. For example, if I take iron oxide, Fe2O3. This Fe2O3, if I employ carbon, what can happen here? I can get the crude metal, along with that I can obtain carbon dioxide. Where if I look to balance these parts here, this is, I can see that I have 2 iron metals here, here also I have to balance it with 2. I have carbon only 1 each on either sides, whereas here it is 3 and there it is just 2. So what we do here is, we multiply this with 2 so that we can get the balancing form of this 3CO2, and to balance this further I need to take this as 4Fe and this as 3C. So what I have done here basically is, I have used carbon as a reducing agent to remove oxygen so that I can get a crude metal. What is the role of carbon monoxide now? So for the same example, I am going to use carbon monoxide, where I can get iron metal and carbon dioxide as the byproduct. Once again, looking into the balancing parts, I have 4 oxygens here, but this side, so this once again I am going to use it as 3CO2 and 3CO, which will help me balance the carbon and oxygen which is being present. So this can be taken as 2 iron. What we try to understand here is that carbon and carbon monoxide can act as very good reducing agents. With this, we can reduce all possible metals which are present but they have various practical issues. What is the practicality? Is carbon good enough to reduce all the metal oxides? That we have to see with various chemical aspects which are being present. Does carbon monoxide reduce all the oxides? We have to see that. And when I have written this reaction, I haven't denoted any temperature or pressure or anything. So, do you think that carbon will directly react with this oxide, carbon monoxide will directly react with this oxide? Is it possible? We have to check it out. If temperature is needed, how much temperature is needed? So, all these factors shall be answered when we study certain thermodynamic concepts of it and Ellingham diagrams, so that we can realize what are the temperatures that need to be involved for these type of conversions to obtain crude metal. Once again, to let you know about the crude metal, it is not a purified metal, it is a metal where all other possible impurities are done away with. So, this is all which has been present for you for the extraction of crude metal. Thank you. Sai Ram.